In our last podcast, we talked about the ERC20 converter, which is now really the SingularityNET ecosystem converter that's recently been released. You can now have your AGIX tokens and your new net tokens on the Cardano blockchain. Can you talk about your experience with the AGIX converter and really how that came to be, and maybe also any technical complexities that you ran into as well?
Yeah, I mean, we decided quite some time ago, really in mid to late 2020, we decided the right path for SingularityNET would be to make AGIX token multi-chain rather than Ethereum blockchain only. Mm-hmm. And then to put the bulk of our focus on the Cardano version of the AGIX token and porting our whole SingularityNET platform onto Cardano, right? And I mean, the reasons for that will be well known to all followers of your podcast, right? I mean, it's among the new crop of faster and cheaper blockchains, and it seemed that the way Charles's head is oriented and the Cardano community is oriented, it seemed like Cardano was going to continue to grow in a direction that was supportive of SingularityNet's aim of creating beneficial, decentralized, artificial, general intelligence. Now, porting SingularityNet platform to Cardano is going to happen in multiple stages. And I mean, to be honest, in late 2020, I thought we were going to be way more advanced by now. Like I thought we were going to make the token converter in early 2021. And that by the end of 2021, we would have ported the full SingularityNet platform to Cardano, right? Now, often in the world of R&D and in version 1 software development, things go a little slower than you would like. So, yeah. And the converter back and forth between the Ethereum and Cardano versions of AGIX token, I mean, this is fundamentally a very simple piece of software, right? I mean, it's converting one currency to another using a given conversion rate. Now, of course, you have to do this sort of thing very carefully because there's potentially very large sums of money involved. You don't want a mistake. You don't want to hack, right?
And that's really where you hear of the biggest problems in our industry is with the bridges. From the conversions of tokens across chains. Is there'll be a smart contract that holds a lot of those tokens, and there's not really a burning function there. So all of those tokens will sit in a contract on Ethereum, and then someone will come in and exploit that.
Yeah. So we did a community vote in SingularityNet community to get permission and support for hard forking the Ethereum AGIX token so it's mintable and burnable, which was to support the function of the converter. And then the Ethereum smart contracts to go from AGIX and Ethereum to AGIX on Cardano were written quite quickly by SingularityNet's blockchain team. What made the converter take a long time was really the other way around. It was just because Plutus wasn't mature yet, right? So we, at first, working together with the IOG team, who were great guys to work with. At first, working with the IOG team, we were working on a sort of shortcut, centralized solution where either Singularity or IOG would host an application that then did the conversion from the ADA version to the Ethereum version of AGIX token. And then, we looked at that and we just didn't like it. We're like, okay, hold on, Plutus is almost ready for this. Why don't we just release it decentralized and do it right? So we decided to eat a little more delay, and we released a Plutus version of the converter once Plutus was ready. And that's, it's more secure and it's philosophically the way it should be done. So I'm happy to have launched it the right way. And now we have AGIX tokens on both blockchains. We don't yet have a full version of the SingularityNet decentralized AI protocol and platform on Cardano. And digging into the right way to do that, it's totally using the Hydra head protocol. So, I mean, Hydra being a sidechain / cross-chain interface to the Cardano main chain, which is quite sophisticated and in a way lets you run Plutus smart contracts that manipulate variables on the side chain or on a foreign blockchain, right? So the Hydra head protocol, will be the first part of Hydra to be released. It takes a set of nodes or agents that are assumed to be reasonably powerful and online most of the time, and lets them interface using Plutus with the Cardano main chain. And that's very much like the multiple state channels and multi-party escrow contracts inside the SingularityNET platform now. So pretty much we're waiting for enough of Hydra to be available and released to port SingularityNET platform in the fullest way we would like to. We've been musing about whether to do an earlier port in this sort of less fully compelling way, like use Mambo to make the EVM version of SingularityNET interact better with Cardano, or port from Ethereum to Polygon, which is very easy, and you use Milkamida to go back and forth. So these would sort of be stopgaps. They could be interesting, but until you've replaced the Solidity with Plutus contracts, which will require Hydra to do it right, then you're not getting the full advantage out of Cardano. But another thing we got out of plunging deep into how Cardano works is realizing that as great as it is, we need something that's even better in some ways to milk everything out of SingularityNet. So we looked at, can we design our own Cardano sidechain, interfacing with the main chain using the Cardano head and tail protocol? Can we design our own Cardano sidechain whose operation is customized for the needs of decentralized AI, and will let us run a huge decentralized AI network very fast and cheap by having consensus mechanisms that are tailored to the fact that this is a subnetwork of decentralized AIs, and that this is what led us to Hypercycle, right? Which is a Cardano sidechain using Hydra head and tail protocol to interface with Cardano main chain, but it doesn't use Ouroboros. It doesn't use any of the standard Cardano consensus mechanisms. It uses Toda, which is a ledgerless blockchain, which is the most disruptive thing in the history of blockchain since probably since smart contracts, right? It uses Toda ledgerless blockchain combined with proof of reputation, which lets agents build up reputation, and then you use that in place of stake or proof of work. So by putting together the Toda ledgerless blockchain with proof of reputation in a network that interacts with Cardano main chain using Hydra head and tail protocol, then you get something that will allow SingularityNet AI network to scale up enough to meet the needs of like a human level general intelligence, or 5 or 10% or 100% of the world's AI processing needs or something. And while Hypercycle goes beyond Cardano in some ways, because Toda gets rid of the ledger and blockchain, which is a new thing. On the other hand, without Cardano, it'll be so much more work to do, right? Because Toda doesn't have a smart contract language. So we want to use Plutus, which matches so naturally with extended UTXO model, and using that and connecting it with Toda is really the magic here. And you need Plutus, right? And there's nothing else like it in the blockchain field.
One thing that I didn't know that you mentioned there that is really taught me a lot in one sentence is this idea that with Hydra, you can write a Plutus smart contract and reference another chain and actually give action to another chain by writing a contract on layer 1. That's pretty crazy to me.
It's cool. And Mambo doesn't do that, as far as I understand. Milkameda certainly doesn't do that. So these are, in a way, a more surface level back and forth between two blockchains, which in many cases is easier, right? Because if you have an EVM application, you may not want to rewrite it to interface at the intimate level with Plutus smart contracts, right? But on the other end, if you're willing to write some more custom code, then you can get a really intimate interoperation between your code either running on another chain or your code running on a side chain and stuff running on the main chain. And I don't know of any other sort of interfacing protocol for another blockchain that is as sophisticated as Hydra. It'll be very hard to do with an accounts-based model like Ethereum or many other blockchains has. It really Hydra, just like Plutus, leverages the underlying elegance of the extended UTXO model quite well.
Yeah. So speaking on the AGIX converter a little more, is this, you mentioned that you guys use Plutus and you used a decentralized way of doing it. Is this open source? Can other projects
It is open
actually
source.
use this?
Anyone can fork it, modify it, and use it for their own tokens. Yeah, I mean, we're going to use it for every token coming out of the SingularityNET ecosystem. So yeah, it's open source.
And essentially the way that works is you have a contract on Ethereum, that recognizes the amount of, AGIX.
That's true. Yeah. So the Ethereum bit is Solidity, and that goes Ethereum to ADA. And a lot of people could write that anyway, and it's fairly straightforward Solidity code.
Yeah.
Then the Plutus bit is what's going from ADA back to Ethereum, and that's still not very hard, but it's a little more recondite, just because Plutus is less well known than Solidity.
How are they connected? Let's say I send 10 AGIX tokens over. How does the Plutus contract actually get that data from Ethereum to then mint the token?
I mean, it's just reads a file. I mean, there's nothing. Actually, the Haskell involved in Plutus smart contract scripting is very, very simple. Any programmer can do it. So what's really hard about Plutus smart contract programming is people aren't used to extended UTXO, and there are very few libraries giving you support relative to Solidity. Actually, the Haskell turns out it's kind of the main thing for the underlying guts of the Cardano platform. But for smart contract scripting, the use of Haskell is really not that sophisticated and not that big a deal. But I can see it's being a psychological obstacle to many blockchain developers now.
Yeah, I've definitely seen that myself.
Yeah, but once they plunge into it, they see, well, wait a minute, the fragment of Haskell used for these smart contracts is very simple. But actually, this other part is really hard. Like, I have to write my own libraries, right?
Yeah.